Hello everybody, getting ready to do lesson 9.5 part 2 pre-calculus math classwork today. And for today's lesson part 2, polar coordinates, you will have 4 points that will go into your notebook or your notebook guide, and 32 points will go into your classwork sheet. Students, name, date, period. Onliners, homeschoolers, put your due date here. And today's bell work. Using the law of sines or cosines, use the law of sines or the law of cosines to solve these two triangles here, students. Teachers, give your students 6 minutes. Pause video for 6 minutes. See you in 6. Okay, welcome back everybody. For our solutions today, we have A equals 56 degrees, C equals 38 degrees, and side length C is 12. With that information here, we have A over sine A, C over sine C, and then for A here we need C sine A over sine C. When we cross multiply and solve for A here, we get C sine, or rather A there, C sine A over sine C will equal, and then we plug in here, 12 sine 56 over sine 38 will give us 16.16 for A. And then for B here, we do the same thing here, the law of sines, and we'll get 12 sine 86 degrees over sine 38 degrees when we plug in our values here. And for B, we get 19.44 length here for B. So we have A, we have B, and then we have C. We have our side lengths there. And then we have 56 and 38. We just use our subtraction of 180, and we find our angle measure for A as well. And then for down here, we have two side lengths, and then we have an angle measure here of B. And for that, we can use our big, long, gnarly manifestation from the law of cosines here to figure out what our B length here is. 29.76. We plug in here our values and we come up with this number here. We take radical square root of that and the square root of B, and we get 29.76 for B. And we have sine C here. Sine C would be our angle measure for C, equals C sine B over B, and this comes out to this number here. And then when we crank that into our calculator, we get our angle measure of 67.1 degrees here for C. And then again, using our subtraction, we get our angle measure for A to be 41.9 degrees. Going into example 4, rectangular to polar conversion. So converting the point -1, 1 to polar coordinates. For the second quadrant point xy, which is -1, 1, you have tan theta will equal y over x. In this case, be 1 over -1, which would be -1. And then a theta for that, our angle measure for that would be 3 pi over 4. So, because theta lies in the same quadrant as xy, use positive r. So r, and when we plug in our values here for x and y, is a square root of 2. Now we got some numbers that we can use to find our point. So one set of polar coordinates would be, r theta would be square root of 2 and then 3 pi over 4. And then that would equal this point here, -1, 1, rather -1 and 1, and our polar coordinates for that be negative, rather the square root of 2 and then 3 pi over 4, and that would be this point. Okay, so let's try one. Plot the point. Here is our point here, given in rectangular coordinates, and find two sets of polar coordinates. Two sets of polar coordinates for the point for 0 less than or equal to theta less than 2 pi. So here is your rectangular coordinate for that. Okay, just saying. And then now for our rectangular coordinates, negative 7, 0, r would equal 7. Here's our length. Here would be 7. Tan theta would be 0. So theta would equal 0. So our polar coordinates in this situation here, for theta to equal 0, it'll be 7 pi and then negative 7, 0. So our polar coordinates would be that. Do the same thing down here, students, on your independent practice. Okay, so equation conversion. By comparing examples 3 and 4, you can see that point conversion from the polar to the rectangular system is straightforward, whereas point conversion from the rectangular to the polar system is more involved. For equations, the opposite is true. To convert a rectangular equation to polar form, you simply replace x by r cosine theta and then y by r sine theta. So r sine theta and r cosine theta for x. For instance, the rectangular equation y equals x squared can be written in polar as here's our rectangular equation, then our polar equation be r sine theta. R sine theta would equal r cosine theta squared. For our x squared here be r cosine theta squared. And then r would equal secant theta tan theta. This would be the simplest form. We're going to move our sine over here, and then we end up with this here, secant theta over tan theta. Remember our trig identities, students. And then on the other hand, converting a polar equation to rectangular form requires considerable ingenuity. Okay, remember that. So converting polar equations to rectangular form, describe the graph of each polar equation and find a corresponding rectangular. For this example here, describe the graph of each polar. We have r equals 2, then find a corresponding rectangular for that. So the graph of the polar equation r equals 2, here would be r equals 2, would be this orbit here, consists of all points that are 2 units from the pole. In other words, this graph is a circle, centered at the origin with a radius of 2 as shown. So here is your graph of r equals 2. You can confirm this by converting to rectangular form using the relationship r squared equals x squared plus y squared. So r squared, this is our polar equation here, then r squared equals 2 squared, and then x squared plus y squared equals 2 squared. This would be your rectangular equation here for that. Okay, for theta equals pi over 3. So the graph of the polar equation, theta equals pi over 3, consists of all points on the line that makes an angle of pi over 3. So this would be your pi over 3 here. It'd be an angle of pi over 3 with a positive x-axis as shown. So it will be right here. To convert to rectangular form, you make the use of the relationship tan theta equals y over x. So theta equals pi over 3. This would be your polar. Then tan theta would be radical 3. And then y would equal radical 3x. This would be the rectangular equation for this line right here. And then C would be r equals secant theta. So the graph of the polar equation, r equals secant theta, is not evident by simple inspection, so you convert to rectangular form by using the relationship r cosine theta equals x. So r equals secant theta, this would be our polar equation, and then this goes to r cosine theta equals 1. R cosine theta equals 1, and then x would equal 1. This would be your rectangular conversion from r equals secant theta, which would be this straight line here. Okay, let's try one now. Describe the graph of the polar equation and find the corresponding rectangular equation. sketch its graph, r equals 6. So, and then down here to students, this is yours. Pay attention up here. The graph of r equals 6 is a circle centered at the origin with a radius of 6 units. T equals 6, r squared equals 36, and then x squared plus y squared equals 36, okay? So how would that graph look like? This would be a graph of r equals 6 right here. So it would be, so r equals 6, you have a radius here of 6 in each direction. And that is 9.5 part 2. Solution PowerPoints are available here, Animated PowerPoint Math Video at AOL.com. For your homework, if you have questions, email me here as well, or materials. Thank you.